Okay, so now we have the rest of, so we did fit the data, but we also want to do this by we fit the data using the FOPTD, but now we want to minimize the sum square error between the model and the data. To do that, we will first be putting in our definite or our function for our sum squared error. So I will define that by sum squared error, and that'll be in our parameter of v. So all of the parameters. And then next, I'm going to return this. And basically here, what we want is the sum of the H experimental, so this, or the H2 experimental that we have from up here. This right here, we want this to be we want that to be subtracted by our FOPTD. So we want to square it, so we want to sum up all of those subtractions so that we basically get this like perfect line that goes right in the middle of our data. And it basically subtracts or adds all of these errors up. So I'm going to do H exp minus our FOPTD, and then in terms of our parameter v, and we also want this squared so that there's no negatives. Like that. And then next we want to go ahead and minimize this, and to do that I will have to add minimize to this, so it imports that and we're able to, I spelled minimize wrong. Very picky. There we go. So I'm going to come back down here and I'm going to set res equal to minimize. And this will just be, oh, and this is, I keep doing this, this is H2. So we want to minimize this in terms of our sum squared error and our v guess. And then we also, oh, I changed that from the last time. So this was FOPTD, but, or sorry, it was just v guess, and now I want to change it to res.x. Then there, and this is, so I'll show you what it looked before. I'll show you what it looked like before. Maybe I can't. Oh, never mind. Okay, I thought I could control Z that. So here you can see that there is data on, now there is data on both sides of this line. So it cuts this, our data perfectly in half and gives us the most perfect line that accurately represents all of our data. Okay, I also want to make it clear. So I showed this portion and I kind of showed that during C after I kind of shift entered everything and put everything through. But this is our closed loop response of the two Tangson series with the step change in the set point. So this was that graph that usually like looked kind of crazy right here and then it went off like that. Or actually it was like crazy here and then went off in the middle, and now it's getting crazy and it goes off to here. W, or frequency, equals np dot log space, and we'll go from this like -2, negative, we'll do negative, and that's to the log, like to the 10 to the 2, so, or that'd be like 100. times 10. And then right here, we'll put this in terms of not just the transfer function forward, but also, what is this doing? But also our frequency. We will run that. And then we will. And again, this just shows us that this never quite gets to 180. So we are stable, and this, the KC values, the controller is perfect.